Hello friends, welcome to H2 Event Academy. In the last lecture, we have discussed up to question number 5. So we will discuss question number 6 onwards in this particular lecture. So basically, we are discussing the problems on the simple harmonic motion. So let's start our discussion. So what is given in question number 5? The speed v of a point P which moves in a straight line is given by the relation v square is equal to a plus 2bx minus cx square, where x is the distance of the point P. So let us consider a SHM like this. So this is our center of point. These are the extreme points. A and A dash are the extreme point. Okay, so the speed v at a distance x from the P from the fixed point on the path. Okay, so the speed v is given as by this expression. V is given by this expression. A v square is equal to a plus 2bx minus cx square, where x is the distance of the point P from the fixed point. So this is fixed point. Okay, and A, B, C are constant. What we have to show? To show First, we have to show that the motion is SHM. Okay, simple harmonic. Simple harmonic. दूसरा, we have to determine the time period and amplitude. And the condition here is that C is positive. Okay, so let's solve this. How we can solve this? So we have V square is equal to A plus 2bx minus cx square. Okay, so let us differentiate this with respect to x. Okay, differentiating. Let us name this as equation 1. Differentiating equation 1 with respect to x. We have 2b into dv upon dx is equal to 2b minus 2cx is equal to 2 of b minus cx. So we have v dv upon dx is equal to b minus cx is equal to minus c x minus b upon c. Okay, so we have the acceleration as, we can write the acceleration as acceleration is dv by dt. Okay, so d2x upon dt square is equal to dv by dt is equal to, we can write this as dv upon dx into dx upon dt, and dx upon dt is v, so we can write it as v dv upon dx. So we can replace v dv upon dx with dx upon d2x upon dt square. So we have d2x upon dt square is equal to minus c x minus b upon c. Okay, so we have the center of force as B upon C. So we have the center of force, and we can compare this equation with standard equation d2x upon dt square is equal to minus mu into x. So this equation is the standard equation of the SHM, provided the center of force is origin. If the center of force is origin, then this is the standard equation of the SHM. But in this particular case, the center of force is force is equal to x is equal to b by c is the center of force, and mu, that is intensity of force, is mu is equal to c. So this is our intensity of force and this is center of force. Okay. So since this equation is similar to the standard equation of the SHM, hence we can say that this motion is simple harmonic motion. Okay, so in the first part we have to show that the motion is simple harmonic. Motion is simple harmonic. The first part we have shown. So now determine the time period. Okay, so how we can find the time period? So the time period is equal to 2 pi upon time period. Time period is equal to 2 pi upon root under mu. So we have mu is equal to c. So this is equal to 2 pi upon root under c. So this is our, sorry, 2 pi upon, this is 2 pi. 2 pi upon root under c is the time period. Now we have to find the amplitude of the motion. So amplitude of the motion is the distance of the point from the center of force where the velocity is 0. Okay. So how we can find this? So we can, let us put the velocity to 0. And first we have to find the, for finding the amplitude, let us determine the points of 0 velocity. Okay, because amplitude is the distance of the point of 0 velocity from the center of force. So we have the center of force as B by C. So we have to find the points of 0 velocity. Okay, so we have this is center of force, x equal to b by c is center of force, and we have to determine the points of zero velocity. So v is equal to 0 and v is equal to 0 here. And at the center of force we have v is equal to v max. Okay, then this is our amplitude. So distance of the point of zero velocity from the center of force, okay, is the amplitude. This is also amplitude. So we have to find these 2 points. Okay, and our center of force is b by c. So we will deduct this coordinate from center of force. So we will get the amplitude. So first we have to find these 2 points. Okay, so let us put this to 0. So 0 is equal to a plus 2bx minus cx square. We have cx square minus 2bx minus a is equal to 0. So we have x is equal to 2b plus minus root under 4b square plus 4ac upon 2c. So this is equal to x is equal to 2b plus minus 2 root under b square plus ac upon 2c. So we have x is equal to b upon c plus minus b square plus ac upon c. Okay, so this point is b square, b upon c. So this point is b upon c plus root under b square, minus, because it is on the negative sign. So this is equal to minus plus ac upon c, and this point is b upon c plus b square plus ac upon c. Okay, this point is a, this point is o, and this point is a dash. So oa is our amplitude. So we have amplitude equal to oa. Oa is equal to, this is b by c plus b square plus ac upon c minus b upon c. So this gets cancelled. So is equal to root under b square plus ac upon c. So we have amplitude. Amplitude is equal to b square plus ac root under upon c, and time period. Time period is equal to 2 pi upon root under c. And constant here is c is positive. Okay. So let us discuss question number 7. So that in a simple harmonic motion of amplitude a and t, the velocity v at a distance x from center is given by this relation. So how we can solve this? So we have the simple harmonic motion like this, and the velocity v at a distance x from the center of force. This is our center of force, and point A and A dash are the extremities. So the velocity v at a distance x from the center of force is given by v square is equal to mu a square minus x square, and we have time period. Time period is equal to t is equal to 2 pi upon root under mu. So from here we have root under mu is equal to 2 pi upon t. So from here mu is equal to 4 pi square upon t square. Okay, so let us place this here. So we have v square is equal to 4 pi square upon capital T square a square minus x square. So from here we have v square t square is equal to 4 pi square a square minus x square. This is the solution of first part. Okay, find the new amplitude if the velocity were doubled when the particle is at a distance of a by 2 from the center. Okay, so let us find the velocity when the particle is at a distance a by 2 from the center. Okay, so let us take this point a by 2 from the center. So let us consider the velocity is v1 when the particle is at a distance of a by 2 from the center. So let us place this in this particular equation. Okay, so we have let when particle is at x is equal to a by 2, velocity v is equal to v1. So we have v1 square t square is equal to 4 pi square into a square minus a by 2 ka whole square, that is a square upon 4. So from here this is equal to 4 pi square into 3a square upon 4. This gets cancelled. So we have v1 square t square is equal to 3 pi square a square. 3 pi square a square. So we have this as v1 square t square is equal to 3 pi square a square. Okay. To find the new amplitude if the velocity were doubled when the particle is at a distance of a by 2 from the center. So what is being asked is if the velocity is double of this v1. So when the velocity is 2v1, what will be the new amplitude? What is new amplitude? Okay, that we have to find. So we have this expression and this expression that we have to utilize. So let us write down at one place. And time period is only dependent on the intensity of force, that is mu. Okay, it is not dependent on the velocity. Okay, so we can use this equation. Okay, on changing the velocity, there is no change in the time period. Okay, so we have v square t square is equal to 4 pi square a square minus x square, and we have v1 square t square is equal to 3 pi square a square. These two equations we are having. Okay, now in the second part, what we are having is that at a distance a by 2 from the center, the velocity is 2v1. Okay, so what will be the new amplitude? So let the new amplitude is a1. Okay, so let us put this in this particular equation. Since time period is not dependent on velocity, we can place 2v1 and x is equal to a by 2 in expression v square t square is equal to 4 pi square a square minus x square. Okay, and the new amplitude is a1. Okay, so we have this as 2v1 whole square t square is equal to 4 pi square. A new amplitude is a1. So this is a1 square minus, at the place of x we have a by 2. So this is a square upon 4. Okay, so we have 4 v1 square t square is equal to 4 pi square a1 square minus a square upon 4. So this gets cancelled. And we have v1 square t square is equal to 3 pi square a square. So we have 3 pi square a square is equal to pi square a1 square minus a square upon 4. So this gets cancelled. So we have 3a square plus a square upon 4 is equal to a1 square. So a1 square is equal to 13a square upon 4. So from here we have a1 is equal to root under 13 upon 2a. This is the new amplitude. Okay. And the new amplitude of the velocity were doubled when the particle is at a distance of a by 2 from the center, period remaining unaltered. Okay. So this is our new amplitude, 13 root under 13 by 2 into a. So the major concept here is that the time period is not dependent on the change in the velocity. Okay. So we have utilized this particular expression and this expression. So now let us solve question number 8. How we can solve this? Show that a particle executing SHM requires 1/6 of its period to move from the position of maximum displacement to one in which displacement is half of the amplitude. So let us consider a SHM like this. So we have the center of force as origin, and this is points of extremity A and A dash. Okay, so this is x is equal to A, this is x is equal to 0, and this is x equal to minus A. Okay, so this is the point of maximum displacement, and this is the point of half amplitude. X is equal to A by 2 is the point of half amplitude. Okay, so we have the expression for the velocity is as v square is equal to mu A square minus x square. So we have dx upon dt whole square is equal to mu a square minus x square. So from here we have dx upon dt is equal to plus minus root under mu root under a square minus x square. Okay, so this point, let us consider the time period to move from the position of maximum displacement to 1. So the particle is moving from A to P. Okay, particle is moving from A to P. So the velocity is dx upon dt, and it is moving in the direction of x decreasing. Okay, so we will take negative sign. We will take negative sign because particle is moving in direction of x decreasing. So we have dx by dt is equal to minus root under mu root under a square minus x square. So from here we have 1 upon root under mu into minus dx upon a square minus x square root under is equal to dt. Okay, so let us consider this total time taken is t1. Okay, so from a to p, the total time taken is t1. Okay, so we have the total time is t is equal to 0 to when x is equal to a, t is equal to 0. So x is equal to a, t is equal to 0. And when x is equal to a by 2, so we have time is equal to t1. So this 1 upon root under mu cos inverse x upon a. This is a by 2 and a is equal to t1. Okay. So we have minus dx upon a square minus x square is cos inverse x by a. Okay. So we have this as 1 upon root under mu cos inverse x by a into a by 2 or 1. So how we can integrate this? So we can solve this here. 1 upon root under mu into cos of x is equal to a by 2. This is 1 by 2 minus cos inverse 1 by 2 minus cos inverse of 1. Okay, this is equal to t1. So cos inverse 1 by 2 is pi by 3. So let us put this, and cos inverse 1 is 0. So we have this as 1 upon root under mu into pi by 3 minus 0 is equal to t1. Okay, so this we can write as t1 is equal to pi upon 3 into 1 upon root under mu. So multiply 2 at the numerator and 2 at the denominator. This we have having t1 is equal to 1 by 6 into 2 pi upon root under mu. And 2 pi upon root under mu is time period, total time period. So this is equal to t1 is equal to capital T upon 6. So this we have to show. Okay, show that the particle executing SHM requires 1/6 of the period to move from the maximum displacement to 1 in. The period is capital T. So the total time taken to move from A to P. This is the point of maximum displacement, and this is the point of displacement that is half of the amplitude. The time taken to move from A to P. From A to P is this T1, and T1 is equal to T upon 6. This we have to show. Okay, so let us discuss question number 9. How we can solve this? A point moving in a straight line with SHM has a velocities v1 and v2 when the distances from the center are x1 and x2. So how we can solve this? So when the distance, this is center of force. So when the position is x1, so we have the velocity as v1. When the position is x2, we have the velocity as v2. So we have the relation between velocity and displacement as v square is equal to mu a square minus x square. So at x is equal to x1, v is equal to v1, and at x is equal to x2, v is equal to v2. So let us put this in equation. So we have v1 square is equal to mu a square minus x1 square, and v2 square is equal to mu a square minus x2 square. Okay, so let us find v2 square minus v1 square is equal to. So we will subtract this equation. So this is equation 1, this is 2, this is 3. So v2 square minus v1 square is equation 3 minus equation 1, equation 2, sorry. So we have v2 square minus v1 square is equal to mu a square minus x2 square and minus a square plus x1 square. So we have v2 square minus v1 square is equal to mu x1 square minus x2 square. So from here we have mu is equal to v2 square minus v1 square upon x1 square minus x2 square. Okay. So the time period is equal to 2 pi upon root under mu. So this is 2 pi upon root under v2 square minus v1 square upon x1 square minus x2 square. So this is equal to 2 pi root under x1 square minus x2 square upon v2 square minus v1 square. So this is the uh, required. This is the time period. Okay. So let us discuss question number 10. Okay. So what is given in question number 10? A particle is moving with SHM while making an excursion from one position of rest to other. It distances from the middle point of its path at 3 consecutive seconds. Okay. So let us take 3 consecutive seconds here. This is the extreme point. This is the extreme point A dash. So this is the center of force. Let us take the position at 3 consecutive seconds are x1, x2 and x3. 3 consecutive seconds how we can take? So first one will be t1. Let us take t1. Second one will be add 1 second. So t1 plus 1. Third one will be t1 plus 2. Okay. So let us make a table. Time and position. Okay, so we have T1, the position is x1. Second, T1 plus 1, the position is x2. Third one, T1 plus 2, the position is x3. And we have the displacement at x is equal to a cos of root under mu into t. Okay, so let us put this. So we have x1 is equal to a cos of root under mu into t1. x2 is equal to a cos of root under mu into t1 plus 1. We have x3 is equal to a cos of root under mu. This is t1 plus 2. Okay. So let us find x1 plus x3. How we can find this? So we have x1 plus x3 is equal to a times of cos of root under mu into t1 plus cos of root under mu into t1 plus 2. Okay. So we have this as x1 plus x3 is equal to a times of cos a plus cos b. How we can find this? Cos a plus cos b is equal to 2 times of cos of a plus b upon 2 into cos b minus a upon 2. This is equal to cos of a plus b, the root under t1 plus a plus b, the t1 plus 2 upon 2. This is 2t1 plus 2. This is t1 plus 1. Okay, cos of root under mu into t1 plus 1. Okay, into cos of b minus a, the root under mu into t1 plus 2 minus t1. This gets cancelled upon 2. This is root under mu. Okay, so now let us further simplify this. And we have the x2 as, okay, this is 2 times. We have 2 times here, no? So x1 plus x3 is equal to 2 times of a cos root under mu into t1 plus 1 into cos of root under mu. And this is this particular expression a cos root under mu into t1 is x2. So we can replace this with x2. So x1 plus x3 is equal to 2x2 into cos of root under mu. So we have root under mu is equal to cos inverse of x1 plus x3 upon 2x2. Okay, this is root under mu. So what will be the time period? Time period is equal to 2 pi upon root under mu. So let us put this. So we have time period is equal to 2 pi upon root under mu. So this is equal to 2 pi upon cos inverse of x1 plus x3 upon 2x2. Okay, this is the required answer. Okay, 2 pi upon cos inverse x1 plus x3 upon 2x2. So similarly, we can solve this. At the ends of 3 consecutive seconds, the distances of the point moving in SHM from the mean position measured are x1 is equal to 1, x2 is equal to 5, x3 is equal to 5. तो टाइम पीरियड क्या होता है? टाइम पीरियड इज इक्वल टू 2 पाई अपॉन थीटा इज इक्वल टू 2 पाई अपॉन cos inverse of what we have found in the last slide, cos inverse x1 plus x3, x1 plus x3 upon 2x2. This is equal to 2 pi upon cos inverse of x1 plus x3, x1 plus x3. This is 1 plus 5 upon 2x2, the 2 times of x2. So this is equal to 6 upon 10. So this is 3 upon 5. So t is equal to 2 pi upon theta is equal to 2 pi upon cos inverse of 3 upon 5. So on comparing, we have theta is equal to cos inverse of 3 upon 5. This is the answer. Okay. Now let us find question number, how we can solve question number 12. This is similar to the previous question solution. So we have time period is equal to 2 pi upon cos inverse of x1 plus x3 upon 2x2. This is equal to 2 pi upon cos inverse of x1 is 1 plus x3 is 4 upon 2x2, 2 into 3. This is equal to 2 pi upon cos inverse of 6 pi upon 6. This is answer. Okay, so we have discussed up to question number 12. We will discuss further questions in next particular lecture. Thank you.